Hey guys, we're ready to do another one. Here we go. At it again. It's 2 a.m. or a little past 2 a.m. and there's nothing I'd rather be doing on this lovely Saturday night or early Sunday morning than this lovely online quiz. And yeah, I do. Let's get started. I'm excited. Let's do it. All right, here we go. So determine whether or not the given function is one-to-one, and if so, find the inverse of this function. All right, so remember what one-to-one means, guys. All it means is that every x has a y, every y has an x. So to put it simply, it has to pass vertical and horizontal, can I even spell? Horizontal line test. So that means if I draw a horizontal line, it cannot cross it more than once. If I draw a vertical line, it cannot cross it more than once. This is a quadratic. All quadratics, none of them are one-to-one, so not one-to-one. I will agree, guys. I got an easy one here. I think when you do your first attempt, I think first attempts are usually easy. I'm not sure because I've been noticing that my first attempts here have been kind of easy here. Determine whether or not the given function is one-to-one. If so, find the inverse. Again, I have a quadratic. All quadratics, they don't pass a horizontal line test. So, not one-to-one. The next one, determine whether or not the given function is one-to-one, and so find the inverse. Again, this is the seventh root. So that one is going to have a one. That is a one-to-one. It's similar to like a square root or the cube root. So every x has a y, every y has an x for it. So here we go. So I'm going to write x equals 2, the seventh root of y. So I'm going to solve for it, guys. Divide by 2, divide by 2. So x over 2 equals the seventh root of y. And I'm going to raise this to the seventh power. Raise this to the seventh power. So now I have y equals x over 2 to the seventh power. And it's going to be all real numbers because you can take seventh root of a negative number. And here it is. Keep going. Determine whether or not the given function is one-to-one, and so find the inverse. Okay, this function right here, because of that, you're not defined at x equals 0. Because you're not defined at x equals 0, that means that not every element has a y value. Because you're not defined at x equals 0, every x has to be paired with a y, every y has to be paired with an x. So this one is not one-to-one. All right, let's keep going. Determine whether or not the given function is one-to-one. Okay, this is a wave, guys. So it just keeps doing this. Obviously, if you have a sinusoidal wave, you're not going to pass the horizontal line test. So it's not one-to-one. All right, let's keep. All right, so here we go. Finally, our first real question that requires us to do a little bit of muscle, a little bit of math stuff. It says, given the following function with k as a constant, find the values of k for which this function is one-to-one. All right. First, I notice that I have x cubed. I have a positive x cubed. So in order to be one-to-one, here's the calculus part. The function f has to always be increasing or decreasing. Because my x is positive here, x cubed, I want this function to be increasing over the entire domain. So I want f prime of x to always be positive. And that way I'm always increasing. All right, so here we go. I'm going to take a derivative, guys. F prime of x equals 3x squared minus 2kx plus 6. Now, I want this to always be increasing, so I'm going to put greater than 0. I see there's equal signs, and I'm not sure if I 100% agree with that, but that's fine. Because I'm looking at like what if I have like a y equals 7? I mean, that's not, that's equaling, the derivative is always 0. So that's a topic for another debate, guys. All right, here we go. I'm going to complete the square right here with these two. I'm going to factor out a 3. So f prime of x is equal to 3, open parenthesis, x squared minus, 2kx over 3 plus some number. I'm going to move that 6 right here, and I want that to be greater than 0. So if I'm completing the square, let's see, 2/3 k divided by 2 is 1/3, and 1/3 k squared is k squared over 9. And I got to balance it. If I put k squared over 9, let's see, that times that is minus k squared over 3. All I'm doing is completing the square, some algebra 2 skills. So now, all I have now is f prime of x equals 3. x minus, let's see, k over 3, close it, squared, plus 6 minus k squared over 3, and that has to be greater than 0. Okay, get up to here. I hope you're not lost, guys. This is just, I'm just doing this online quiz here for those of you that are new to the channel or new to this question. Hopefully you can find a lesson somewhere on completing the square and what that means. That's all I did. I just completed the square. This that I'm circling is always positive. Always positive. So I don't have to focus on that. It's always positive or 0, I guess. You can be a 0. But it's always positive because of that squared. So I turn my attention to this right here specifically that I circled in red. I need that to be larger than 0. So I write 6 minus k squared over 3, and I need that to be larger than 0 because it's possible for what I circled there in blue to be 0, right? All right, so now I'm just going to solve for k, guys. I'm going to move the k squared over 3 to the right. So I have 6 is greater than k squared over 3. And I'm going to rewrite this, guys, because I like to have what I'm solving for on the left-hand side. So I'm going to write k squared over 3 is less than 6. So times 3 times 3. And I'll have k squared is less than 18. And I'm going to come to this little, right here, this little white space here. I'm going to take the square root of this. Now remember, when you take a square root of something squared, it's plus or minus. So I need k to be smaller than the positive square root of 18, but bigger than the negative square root of 18. All right, so that's my plus or minus from Algebra 2. I didn't do anything crazy, guys. So now I look for my answer, and we'll have to reduce this. Let's see, 9 times 2 is 18, and the square root of 9 is 3. So k must be smaller than 3 square root of 2, but larger than negative 3 square root of 2. I don't 100% agree with those equal signs. I guess they're assuming that what I have here in blue will not be 0 when k is at those maximums. Yeah, that's another debate, guys. I prefer no equal signs in the bottom. I guess I'll chat with a few professors to see what's up. But here it is. All right, guys, let's go to the next one. Suppose that f has an inverse, f of 5 equals negative 5, f prime of 5 equals 6 over 11. What is the derivative? There's a little prime right there. What is the derivative of the inverse at negative 5? Recognize that that negative 5 was a y value. So that means I'm looking specifically when x is 5. So, Chavez, what are you talking about? So the derivative at negative 5 is nothing more than the reciprocal of f prime of 5. Well, f prime of 5 is 6 over 11, so the answer must be 11 over 6. Now, in case you don't understand, guys, why the derivative of the inverse is the reciprocal, you have to have like a lesson on inverses. I'm not trying to do a lesson for these online quizzes. I'm just trying to solve them. But real quick, when you find an inverse, remember that it reflects across the line y equals x. So if I have some function like an exponential here, and then the inverse of an exponential is a logarithm, well, remember, this point AB is going to be this point here, BA, right? And if I find the tangent slope of that, well, that means f prime of A equals some number. And well, if I find the tangent slope at B, trying to make them intersect there. Well, the tangent slope at B, since they're inverse of each other, guys, it has to be whatever the reciprocal is of A, of f prime of A. If I call this G prime of B, remember that I'm saying that f and G are inverses of each other. And then that's a reciprocal of f prime of A. See? So I hopefully that makes sense, guys, for you guys, that f and G are inverses of each other. So I guess I should be writing G is the inverse of f there. So there it is. I tried to make a quick lesson out of this. My apologies if it's taking too long. Let's go to the next one. Suppose that f of x equals negative 4x cubed minus 1 is differentiable and has the inverse function that. Find the derivative at negative 5 again. So I'm going to be focused on this 1 there. If I want the derivative at negative 5, I'm not going to find the inverse function, guys. You can if you want to, but sometimes it's cumbersome. Just take the derivative of this function. f prime of x is equal to a negative 4 times 3 is negative 12x squared. The 1 is a constant. I'm going to plug in a 1. So negative 12 times 1 squared. So I get negative 12. And then I just take the inverse of that. So I know that f of negative 1, the inverse of negative 1 at 5 is nothing more than 1 over f prime of 1. This is the original here. So negative 1/12. Let's go to the next one. Suppose that f of x equals blah, is differentiable and has an inverse. F of 1 equals 8. Find the derivative of the inverse at 8. Again, I'm focused at f of 1. I'm going to take the derivative at 1, and I'm going to just take a reciprocal. Have I been saying the word inverse? My apologies. I'm going to take the reciprocal of that. So here we go. F prime of x equals 2 plus, this is 6 squared of x, so half of 6 is 3. X to the negative half. And that's it. That's everything. I'm going to plug in a 1. F prime of 1 equals 2 plus 3 over square root of 1. So I get 5. So the reciprocal of 5 is just 1/5. Alright, let's go to this last question here. Suppose that f of x equals x plus 2 over x minus 1 is differentiable and has the inverse. F of 3 is 5/2. Find the derivative of the inverse at 5/2. Again, I'm focused at that 3 there. I'm going to take the derivative. You could always find the inverse function for this one, guys, but I'm just going to take the derivative and plug in a 3. So here we go. F prime of x equals bottom, x minus 1 times root of the top, which is 1, minus top, x bottom times root of the top minus top times root of the bottom, times 1 all over bottom squared. I'm going to plug in a 3. 3 minus 1 is 2. 3 plus 2 is 5. All over 3 minus 1 is 2. 2 squared is 4. So it looks like I'm getting negative 3/4. So now I'm going to take the reciprocal of that number. So my answer, the inverse, the derivative at 5/2, is nothing more than a negative 4/3. Alright guys, I hope you guys enjoyed this channel. I enjoyed doing this online quiz at this time of night. I hope you guys enjoy this one as well. And have a good night or a good day or good morning or whatever day that may be. And I'll see you guys soon. Alright, talk to you guys later. Bye.